Chapter 15, Properties of Gases. This lecture will help you understand the ideal gas law and vapor pressure and humidity. Joseph Louis Gay-Lussac was a French experimentalist. He experimentally found that at constant volume, pressure and absolute temperature are directly related. Amedeo Avogadro was an Italian physicist. He experimentally found that at constant temperature and pressure, the volume of a gas is directly related to the number of moles. By adding molecules to a gas, the volume of a gas must increase. John Dalton was an English chemist and physicist. He found that the total pressure in a container is the sum of the pressure of each gas would exert if it were alone in the container. The total pressure is the sum of the partial pressures. The figure shows the application of Dalton's law. The container on the left has 0.6 moles of molecular hydrogen at a pressure of 2.9 atmospheres. The middle container contains 1.5 moles of helium at 7.2 atmospheres. Both containers are at the same temperature of 20 degrees Celsius. When mixed together at 20 degrees Celsius, the total pressure is the sum of the individual pressures, yielding 10.1 atmospheres. Renaud Clapeyron was a French engineer and physicist, one of the founders of thermodynamics. The ideal gas law is called an equation of state and was first stated by Clapeyron in 1834 as a combination of the empirical Boyle's law, Charles's law, and Avogadro's law. It is a good approximation of the behavior of many gases under many conditions. The ideal gas law is often written as PV equal nRT, where P is the pressure, V is the volume, N is the number of moles of a substance, R is called the ideal gas constant, and T is the temperature. Blowing up a balloon means putting more air, more molecules into the balloon, which increases its volume. The pressure is nearly constant, atmospheric, except for the small effect of the balloon's elasticity. If the number of molecules in a gas remains constant, then the ideal gas law can be written as the pressure times the volume divided by the temperature of the initial state of the gas, which must equal the pressure times the volume divided by the temperature of the final state of the gas. What can happen if you throw an empty glass jar with the lid on tight into a fire, and why? The jar is filled with air, which will not be able to expand in the heat of the fire. Instead, the pressure inside the jar will increase, perhaps to the point where it blows the jar apart. The ideal gas laws are reasonably accurate except at very low temperatures and under extreme pressures. A commonly used reference in gas laws is called the standard temperature and pressure, STP. Standard temperature is the freezing point of water, 0 degrees Celsius or 32 degrees Fahrenheit. Standard pressure is equivalent to atmospheric pressure, 101.32 kilopascals or 14.7 pounds per square inch. When a liquid evaporates, molecules of the liquid pass from its surface into the air above the liquid. This increases the number of molecules in the air and causes an increase in the pressure above the liquid. This increase in pressure is called vapor pressure. The gas produced by the reaction displaces the water, which is denser, in the collection bottle. You can apply Dalton's law of partial pressures in calculating the pressure of gases collected in this way. A gas collected by water displacement is not pure, but is always mixed with water vapor. That is because water molecules at the liquid surface evaporate and mix with the gas molecules. Water vapor, like other gases, exerts a pressure known as the water vapor pressure. According to Dalton's law of partial pressures, the total pressure is the pressure of the gas plus the pressure of the vapor. To get the gas pressure, you must subtract the vapor pressure. Condensation is the change of the physical state of a matter from gas phase into a liquid phase, and is the reverse of evaporation. Humidity is the amount of water vapor in the air. Absolute humidity is the amount of water vapor divided by the amount of dry air in a certain volume of air at a particular temperature. The hotter the air is, the more water vapor it can hold. Relative humidity is the ratio of the current absolute humidity to the highest possible absolute humidity, which will depend upon the current air temperature. Relative humidity is the term weather forecasters use most often. Dew point is the temperature to which air must be cooled to become saturated with water vapor. When further cooled, the airborne water vapor will condense to form a liquid. In Phoenix, where the humidity is very low, evaporation is substantially greater than condensation. In New Orleans, however, where the humidity is much higher, condensation is much greater and offsets evaporation, so people are more uncomfortable as condensation limits the cooling effects of the evaporation of a person's perspiration. For most people, a relative humidity of 50 to 60% at about 20 degrees Celsius is comfortable. When the relative humidity is higher, the air feels heavy and uncomfortable. Steam burns can be very dangerous, since steam gives up considerable energy when it changes from vapor to liquid, about 540 calories per gram per degree Celsius. Getting burned by steam can be much worse than getting burned by water at the same temperature. The following are a set of problems for you to work on. Pause the video to give yourself time to work on the problems. A gas occupies 450 cubic centimeters at 30 degrees Celsius. At what temperature will the gas occupy 480 cubic centimeters? Pause the video to work on the problem. The initial temperature must be converted to Kelvin, yielding 303 Kelvin. Using Charles's law, the final temperature is 50 degrees Celsius. Oxygen occupies 500 cubic inches at an absolute pressure of 40 psi. What is the volume at an absolute pressure of 100 psi for the same amount of gas? Pause the video to work on the problem. Using Boyle's law, the final volume is 200 cubic inches. Five cubic meters of acetylene at 4 degrees Celsius, or 277 Kelvin, has a pressure of 160 kilopascal absolute. What is the pressure if the volume is changed to 4 cubic meters at 30 degrees Celsius, or 303 Kelvin? Pause the video to work on the problem. We use the ideal gas law and get a final temperature of 219 kilopascals. Your homework assignments are to read Chapter 15 in the textbook. Your homework assignment does not have a due date.